Welcome to the Explainer. So picture this. You're in a massive industrial plant. How on earth do you decide what to inspect? Today, we're digging into something called risk-based inspection, or RBI. It's a really smart way to work that's less about just being busy and way more about being effective. All right, let's dive right into the core problem. Every single large industrial facility, think of a refinery or a chemical plant, they all face this same huge dilemma. You've got thousands of pieces of equipment. What do you inspect and when? For the longest time, the options, they weren't great. On one hand, you could try to inspect everything on some kind of fixed schedule. But that's just crazy expensive and inefficient, right? You're treating a supercritical pipe the same way you treat a totally harmless one. Then there's the other option. Fix it when it breaks, which, let's be honest, is basically just waiting around for a disaster to happen. It's completely reactive and just unacceptably dangerous. So clearly, a better way was needed. And that is exactly where risk-based inspection enters the scene. It offers a much more intelligent and focused strategy. So what is RBI exactly? Well, it's really a method for focusing your limited time, money, and people where they'll do the most good. So instead of inspecting everything on a rigid calendar, you concentrate all your efforts on the equipment that poses the biggest risk to people, to the environment, and of course, to the business itself. And here's the really cool part. RBI doesn't rely on gut feelings or just, how we've always done it. It actually defines risk with a surprisingly simple calculation that's based on just two key ideas. First up, we have the probability of failure, or POF, and it's pretty much what it sounds like. What's the chance that something is going to fail? You're asking, what are the odds that this specific pump or that specific pipe is going to break? And the answer, well, it depends on its age, what it's made of, the conditions it's operating under, all that stuff. Okay, so that's one half of the puzzle. The second component is the consequence of failure, or COF. This asks the really critical follow-up question. Okay, and if it does fail, how bad is it going to be? And this looks at everything: potential injuries, environmental damage, the financial hit. A tiny harmless leak has a very different consequence than a massive toxic release, right? And that brings us to this simple but incredibly powerful equation. Risk is probability times consequence. Just think about that for a second. Something that fails all the time but has basically zero impact, that's a low risk. But what about something that's super unlikely to fail, but if it did, it would be absolutely catastrophic? Well, that's an extremely high risk. And this is where it all comes together. This is the central tool of RBI, the risk plot. You get every piece of equipment and you plot it on this chart. Probability on one axis, consequence on the other, and bam! You get an instant visual map of your priorities. Everything up there in that top right corner, that's where you need to focus your attention right now. And this is a huge but. For this entire system to be reliable, for that risk plot to actually mean anything, it all hinges on one absolutely critical factor: the quality of the information you feed into it. This is the absolute golden rule of RBI, and it's so important. Your risk calculations are completely worthless if they're based on bad data. The entire assessment, the whole thing, depends on having valid and reliable information. Garbage in, garbage out. Okay, let's use a dartboard to make this super clear. The ideal state for your data is what you see here. It's both accurate and precise. Accuracy means your measurements are correct. They're actually hitting the true value. And precision means they're consistent and repeatable. You're hitting the bullseye every single time. This is what high-quality data looks like. But now look at these other two scenarios. In the middle, our data is precise, but it's not accurate. So we're consistently hitting the same spot, but it's the wrong spot. This is really dangerous because it gives you a false sense of confidence. You think you know what's going on, but your entire understanding is off. And on the right, the data is accurate on average, but it's not precise at all. The measurements are all over the place. This is also a huge problem because that inconsistency makes it impossible to spot any real trends. Either of these situations will lead you to misjudge the risk and focus on all the wrong things. So what happens when you get the data right and you apply this methodology correctly? Well, the payoff is huge. It really fundamentally changes the outcome of your entire inspection program. This graph tells the whole story in one simple picture. That top curve, that's your typical time-based inspection program. Yeah, you do more inspections and the overall risk goes down, but only to a certain point. But that bottom curve, that represents an optimized RBI program. Now, for the exact same level of inspection activity, the same amount of work, you achieve a significantly greater reduction in risk. Why? Because every single action is targeted at the most critical items. At the end of the day, RBI lets you work smarter, not harder. You're not just spending resources anymore, you're strategically investing them where they have the biggest possible impact. You are quite literally buying more safety and more reliability for the exact same amount of effort. Ultimately, risk-based inspection changes the fundamental question you ask. You stop asking, when was this last inspected? And you start asking, what is the risk if this fails? It transforms inspection from a reactive chore into a proactive strategy. It's a really powerful shift from focusing on what might break to focusing on what truly matters. And that makes you wonder, doesn't it? Where else in our work, or maybe even in our lives, could we apply that same kind of thinking?